What is chemistry? Everything is made of chemicals. You are made of chemicals. So is your dog, so is your desk, so is the sun. Drugs are chemicals. Food is made from chemicals. Why do we study chemistry?
Is it because understanding chemistry helps everyone to distinguish the things around the world?
When you study chemistry, you come to understand a bit about how things work. Chemistry isn't a secret knowledge, useless to anyone, but an explanation to everyday things. Good day to all of you. I am here to report or to discuss about the elements, the compounds, and the mixture. So I have here an example of an element which is a silver, and we have to note that an element is comprised of one atom and it cannot be broken down into smaller type of matter, even physically means or chemically means. It can also be existed either as an atom or a molecule. And as we all know, a molecule is comprised of two or more same elements or different elements that are bounded together. Note that the two nitrogens which comprise a nitrogen molecule can move. Next thing that I have here is a table salt, which is an example of a compound. And in terms of compound, we have to take note that it is composed of two or more elements that are chemically bounded together. In this example, we combine sodium and chlorine. In compound also, it can be broken down into smaller or simpler type of matter or an element, but in chemical means and not by physical means. It has also properties that are different from its component element. And the last thing is it always contains the same ratio of the component of atoms. So the last thing that I have here is the sugar plus the water. So this is what we call mixture. And in terms of mixture, we have to note that there are two or more elements or compounds that are physically intermingled, just like what I have done. And the next thing is it can be also broken down into its original components by physical means. And the last thing is it often retains in many of the properties of its components. And that would be all.
Accuracy and precision. Measurements are an important part of doing experiments. Two different and often confused concepts pertaining to measurements are accuracy and precision. Accuracy is how close the true measurements are. Measuring devices or techniques can easily be inaccurate and lead to false measurements, and no matter how accurate a device may be, there is still a tolerance for error. No measurement is perfect. Accuracy must be accounted for in your results. Precision is how consistent your results are for the same phenomena over several measurements, or how repeatable a device's performance can be made. Precision as a measure of variation must be accounted for in your calculations and results.
Welcome to the world! Welcome to the world!
Go Billy! Go Billy! Wow! Why? Go Billy! Go Billy! Wow! Why? Go Billy!
Welcome to the world! Welcome to the world!
Physical and chemical changes. Chemical changes takes place on the molecular level. A chemical change produces a new substance. Examples of chemical changes includes combustion or burning, cooking an egg, resting of an iron pan, and mixing hydrochloric acid and sodium hydroxide to make salt and water. Physical changes are concerned with energy and states of matter. A physical change does not produce a new substance. Changes in state or phase like melting, freezing, vaporization, condensation, and sublimation are physical changes. Examples of physical changes includes crushing a can, melting an ice cube, breaking a bottle, and crumpling a paper. How to tell chemical and physical changes apart? A chemical change makes substance that wasn't there before. There may be clues that a chemical reaction took place, such as light, heat, color change, gas production, odor, or sound. The starting and ending materials of a physical change are the same, even though they may look different.